Okay, thank you for attending this Pixie Software session. I'm Geoffrey Subileau, in charge of brand development at PiXYZ.
And my name is Axel Jacquet. I work at PiXYZ as a product manager and professional services manager. And the purpose of this session this morning is to present to you PiXYZ data preparation solutions through actual industrial use cases, and from an interactive data prep mode to a fully automatic and scalable mode.
Just before digging into that, how many of you already deal with importing CAD data into Unity? Wow, okay. Great, and how many of you already heard about PiXYZ? Wow, almost same. Stefan. Okay, so...
Yeah. So, yeah, for those who wouldn't know Pixie Software, just so you know that it's a company that basically provides solutions for CAD data preparation and optimization. And all the solutions that we're going to present, they all share the same core of advanced optimization algorithms.
And a little bit of history. PiXYZ Software is a spin-off of a VR AR agency called Light and Shadows. They had to deal with lots of CAD data coming from their customers. So they started PiXYZ as an internal project. And in fact, we see more and more industrial companies now want to reuse their CAD data for real-time applications built in game engines. And I think this is going mainstream. And so that's the purpose of PiXYZ. At PiXYZ, the team is made of automotive experts, CAD modeling tool experts, and also VR, AR experts. So earlier this year, we announced a strategic partnership with Unity. And this is why we are here. We'd like to thank Unity for welcoming us. And along with this partnership, Unity announced its commitment to the automotive industry, as you know. So today you can buy a Unity for Industry bundle containing Unity Pro and PiXYZ products inside. Of course, we will work closely with Unity to provide you with the best and smoothest CAD data management experience. So if we look at the 3D experience creation value chain, we try to fill the gap between CAD modeling tools and staging tools like Unity. We'd like somehow to be like a hub for any CAD data input to any kind of use cases. And our solutions can be used whether by a single person for manual data prep or deployed globally in the company for extensive use. And in this case, we work very closely with the customers to help them to build large-scale automatic CAD data preparation pipelines. Very quickly, this is our portfolio as of today. We have CAD data prep tools, and we have also on the left, on the right, a CAD file review called Review. But for this talk, we'll focus on those three. Plugin, which is, as you may know, the direct CAD file import in Unity. Studio, which is our prime interactive complete toolbox for CAD data preparation. And Connect, which is the solution to deploy automatic CAD data prep globally in the company.
So, now that you know a little bit more about Pixie Software, let's take some real industrial use cases to present to you the three solutions for data preparation that Geoffrey mentioned. So, PiXYZ plugin for Unity, PiXYZ Studio, and Connect. For the purpose of this demonstration, we are going to use these models that was provided by our friends at Toyota, which is the Lexus LC500. And basically what we have as input file there for this use case are thousands of 3D models coming out of CATIA, which is, as you probably know, one of the most used CAD data software, CAD design software on the market. So basically, there can be one PiXYZ product for each use case. Depending on the complexity of the use case, you'll be willing to use either one. So to simplify, if your project is to quickly and easily bring CAD data inside Unity, then Pixie plugin is the one you will be using because it's more fit for small assets like car brakes, for example, or up to medium complex assemblies. All right? If you're working on a full car, just like this Lexus, then it's a heavier, more complex model, and Pixie Studio is the tool you should go to. Because basically, as Geoffrey said, Studio is the original Pixie tool, embedding all the algorithms that we ever produced for Pixies. And finally, if you wish to scale and repeat data preparation, treat many models according to predefined scenarios, well, basically make data preparation available for anyone in the company, then Pixies Connect is the solution. So, well, based on this criteria that we see here, you're going to have to choose your solution from an interactive usage to a fully automated usage. So then you have to choose your weapon. So let's start with the real use case. And the very first one, quite simple, which required to, let's say, import a CAD file, a small one, to create a simple VR experience application for CAD model review using Unity. In that case, we're going to take the car brakes from the Lexus. Well, for this typical case, Pixie's plugin for Unity is the right choice. And basically, the plugin comes as a simple Unity package. Very easy to install, very easy to use, with the possibilities to import more than 20 different CAD formats, which is quite important, and directly inside Unity. And it comes as a simple interface with understandable and simple settings and presets. So basically, you have a bunch of group boxes, and you have to go through these settings to finally import your model inside Unity. So first, you'll get to choose your input file. Then you can conform coordinate systems from and units inherited from the CAD model that you're trying to import to your Unity project. Then you have presets to deal with the hierarchy, or what we call product structure when we talk about CAD models. So basically, you can merge, you can compress, you can merge by materials, you can do a lot of things. But that's something very, very important for industrial customers, the hierarchy thing, because with plugin, we managed to preserve all information coming from the original CAD file, and that's very important. Like this, you can ensure digital continuity between CAD software and staging tool like Unity. So if you go into details, we have, so as I was saying, you will have the exact same hierarchy as what you would have in CATIA, in the Lexus case. We also keep instances, which can be very important for some performance issues. We also keep the material color assignment. And finally, in the next version of Pixie's plugin for Unity that will be released next month, we also import metadata that will be delivered in components on parts. These metadata are very important information that engineers just put inside 3D models in the PLM system that can be very powerful to use for advanced data preparation or scripting inside Unity. Then, well, you move to the mesh quality group box. So basically, it's where you will define the quality of the meshes that will be created by Pixie's core algorithms. So it comes as very simple presets, and so that the user benefits Pixie's expertise. No hard settings, not easy to understand. You don't need to know about that. We did that for you. Then, a common concept between Unity and the plugin, you have the possibility to create LODs on the fly simply by choosing the mesh quality for each LOD. Then you have some advanced settings in which you will be able to create some UVs, so by projections, simple UVs for the first channel. And you also have the possibility to let Pixies handle mesh orientation if necessary. So after importing phase using the plugin, you end up with a ready-to-use asset inside Unity, and on top of which you get to use Unity power to add behavior for a VR use in our use case here. And then you finally build the final application in Unity. And this is the result here is an Oculus VR app for CAD model review built with Unity. So with some simple interactions, you can explode, you can grab, you can do some cutting planes. So for CAD model reviews, this is very interesting and very easy and fast to do with the plugin. So that, oh, no, sorry.
Yeah, and there is another interesting feature. This is the ability to import CAD files at runtime using the plugin. So far, this is possible only on Windows. But we hope so to support more platforms.
Yeah. So, in conclusion, we can say that the plugin is quite the automagic tool. It's good for non-CAD specialists that need to quickly bring some CAD data inside Unity. But at some point, it gets limited because you don't have the opportunity to choose your own advanced strategy for data preparation. So, because plugin is just a subset of Pixie's core. So if you want to move forward to some more advanced data preparation, you should move to Pixie Studio. That's use case number 2. For this use case, what you want to do is to create a full car model with materials applied on it for design review inside Unity. So more complex topic. And so for this advanced interactive data prep, Studio is the rightful tool. With Studio, you get all the import and export formats that we handle, and it comes in a very ergonomic, intuitive UI, and more importantly, with a very robust and powerful viewer, which is really necessary to be able to display such a heavy car assembly, of course. And as I mentioned before, Studio is the original tool with all Pixie's core algorithms, with no limitation. So, as I was saying, for dealing with such complex data, we have to bring all the weapons that we can have from Pixie's core. So the goal here is to prepare this Lexus for Unity. So I'm going to present to you the main algorithm that we have whilst preparing this core. So the very first step would be to import the files. For this car, it represents more than 3,000 CATIA files, which is a lot. What you get in this stage for the moment in the studio environment are not meshes. These are original CAD surfaces, mathematically defined, and that's what is represented here as a gray wireframe. Once you have a complete car inside studio environments, which is already a performance to my point of view, you can move to actual data preparation steps. So the very first step you can take is, prior to creating meshes, you're going to prepare your car to be tessellated, to create meshes. But the first step would be to repair the original CAD data I was talking about. The goal here is to remove some potential overlapping surfaces, to stitch together some potential gaps, and also, and very important, to merge together some shattered surfaces that need to be connected together in order to create some good meshes afterwards. So after this part, we come from 3,000 parts to less half of it. So it's already starting data optimization from this step. Then, of course, the next move would be to create meshes using our best-in-class tessellation algorithms. And for this whole car, exterior plus interior, we get 4 million triangles in total, which is quite limited, still with a good quality, visual quality. And as we did for CAD surfaces, what we can do now is doing some mesh repair. What you can see as some pink faces, or all the faces are misoriented. That's the way we display that in Studio. And that's very important to have some well-oriented meshes when you get to Unity. So the repair phase is going to try to potentially also repair some gaps or remove some unnecessary polygons or edges, but more importantly, it's going to try to orient correctly all the faces of the model. But sometimes it's just not enough. So you have to do some more optimization to have a fully well-oriented car. This is why we have a script called a new script called Smart Orientation that is perfect for this kind of full car assembly, and that will automatically orient the faces. Basically, how it works, it consists in automatically placing cameras in the cavities of the car, and all the faces will be oriented by sort of looking at the scatter camera all over the model. So next, you can move on to material assignment. So the idea here is to apply materials to each part of the model, but remember that for this use case, what we want is to end up in Unity. And we want to apply to the Lexus some materials from the future Unity automotive library that is going to be released this year. So what we simply need to do is to apply some materials that have the same material names than the one coming from the Unity material library. Then you can move on to creating some UVs. We have several algorithms available to create UVs in Studio, and also powerful repack algorithms that can be potentially necessary for baking light maps in Unity. This is not the case for this rather simple use case. Finally, and it's also an important step here, is the tree optimization, the product structure optimization. What you can do here, you can merge parts together to create sub-assemblies. You can potentially merge them by materials, stuff like that. You can create symmetries, instantiated symmetries. So you're optimizing the project structure, which is good for Unity. Like this, it will have a simpler scene graph to handle inside Unity. And the final step now would be to export the final model that we prepared with this step-by-step procedure to any of the format that we handle in Pixie Studio. It could be FBX, it could be GRTF. But for the purpose of this demonstration, we're going to go with the Pixie's formats. And why is that? It's because we want to take advantage of our plugin for Unity. Using the plugin plus our Pixie's proprietary formats, you will be able to import more efficiently the final model inside Unity than what you would do with an FBX. And also, providing that your final project contains the material from the Unity automotive library I was talking about before, then materials will be automatically applied, which gains a lot of time. So in the end, you end up with this, a full car model, fully dressed with materials, beautified for a design review inside Unity. Now in this example, I did not show you all Pixie's main algorithms, so I'd just like to talk about a few ones that we have. For example, defeaturing. Defeaturing is going to allow you to, for example, do some geometric defeaturing, removing holes like through holes, blind holes, surfacing holes. But you can also do some defeaturing based on other properties. Like you can remove small parts, and you can also target some metadata to do some specific defeaturing following any metadata that is available inside the original part. Then we have the smart hidden removal, which is quite the same concept that what I showed you with the smart orientation. Basically, what we are going to do, again, is to scatter some cameras all around the vehicles and inside, looking for cavities. And basically, any polygons that won't be seen by one of these cameras will simply be removed. So you can gain a lot of polygon budget by using this. And it's very interesting. It also works better on the full car model, like here. Another important algorithm that we have is the proxy mesh. Basically, it's just an algorithm to help you create automatically an envelope of your mesh that can be used then in Unity for either shadow mesh or collision meshes. So it's an automatic phase also. And in the next version of Pixie Studio that will be released very soon, we have some new algorithms, for example, the polygon target decimation. So far, we have an algorithm for decimation which is based on quality criteria. And now we have developed this new one that's based on the number of polygons that you want to achieve in the end. So two different approaches. that can be used for any for the rightful use case. Very important for this new version, we now can create some maps, some texture maps for, by baking, and basically you will end up with some normal maps, some diffuse maps, and some material ID maps. And finally, we also made some ready-to-use scenarios to help people getting started with Pixie Studio, because we know it can be a lot of complex strategies and complex step-by-step procedures. So these examples are here to help the people create their own step-by-step procedure that will fit to their needs. And these 3 new algorithms will be released in the 2018.2 release in July. So let's move on to use case number 3. Now that we did the number 2, how to automate this process, how to make it automatic. Now that we tailored good data prep recipe interactively in the number 2 use case, how can we deal with the full 150% model of this Lexus and import in Unity? Well, for that, you get to use the power of our embedded Python API that will allow you to do some scripting, which is very, very powerful. Now, the Lexus model coming from Lexus PLM is completely disassembled, as I said before. It's thousands of CATIA parts. And so thousands of unitary CAD files combined together makes what we call the 150% model of the car. And meaning it's all the existing variants of the model combined in just all these unitary CAD files. And now we need to build automatically a car. How can we do that? What rule can we follow? Well, at Lexus, they have what we could call an internal solver, which is basically a big fat tab that says which unitary parts should be assembled for each variant, and what material should be applied to this part, and which group should it be linked to. So does this part need to go to the left door, to the seat, to any part of the model? So what we did is basically create a scenario that basically is going to read this tab, which serves as a rule engine, and load intelligently all the parts, and execute the step-by-step prep scenario that we saw in the previous use case. And finally, you end up in Unity with a fully prepared and packed 150% car assembly. And on top of that, if you want, you can create a solver to create a functional car configurator, for example, with multiple variants.
So at the end of the project, with the Lexus, the car data we prepared were used to, by the VR agency Light and Shadows to create this marketing car configurator in Unity that you are able to see on our booth downstairs. So the next step would be to deploy a CAD data-driven experience generation platform at Toyota, and where we could have Unity applications to be generated on demand. The idea is to connect the product lifecycle management system of the company to Pixie's Connect platform, which will then feed Unity experience templates with fresh and optimized CAD data. And the car configurator we've just shown you is an example of an experience that could be templatized. So Pixie's Connect front-end looks like this. So it's deployed on-premise, on customer's premise. It's administrated through a web page. And typically, the user will select the CAD data input, then chooses an optimization scenario that has been coded in Pixie Studio or using the Python scripting API. And at the end of the process, the user downloads the result, whether it is an optimized asset or a built application if a Unity application template has been provided.
So just in conclusion, we just want to tell you that we did a product restack for the next version, 2019.2. So now we have all this portfolio. We have Pixie's plugin for Unity, Pixie Studio, Pixie Studio.batch, Pixie's Connect, and a little bit aside, Pixie's Review. Just to mention one important feature for each of these products, the Pixie's plugin, you will be able to have either a developer license or a runtime-only license. For example, if you wish to create your own applications, embedding the Pixie's plugin for Unity to allow your customers to load some CAD data on runtime mode. The Pixie Studio, it's basically the one that we have today, so it's all the interactive tools, but additionally, now the Python scripting API is included in the offer. And we have a new version which is called Pixie Studio.batch that's basically is Studio, but additionally you have a token for import and export through the Python API so that you will be able to batch process CAD data inside Studio directly. And Pixie's Connect, Geoffrey just told you what it is, this SaaS data prep solution. And just a few words about Pixie's Review, which is our desktop immersive and collaborative CAD visualization tool.
Okay, thank you for attending this presentation. Just to let you know, so I said we have a booth downstairs. We have 3 demos. One is Pixie's Connect, where we can automatically prepare some CAD files in order to use it on a tablet, iOS, with some AR functionalities. We have an iterative CAD design review going from SolidWorks to Unity, lively almost. And it's also used the Interact product of Light and Shadows, which is a toolbox in Unity to ease the development of VR application. And you are also able to see the car configurator of the Lexus using the ArchDAP Unity engine. Thank you.
Thank you. Minutes. Do you have any question, maybe? I don't know if we have time to take a few questions. Go ahead.
You're focused on automotive. What do you think other industrial products, how good would Pixie Studio or the other products fit for that?
Yeah, you mean other markets, like, do you have any industry in mind? You mean beside
well,
all industries using CAD? Yeah, we work with train manufacturing companies like Alstom, Siemens. So any company that is using CAD data is a target to use Pixie's software solution, because now those companies, they want to reuse their CAD data for any kind of purpose, especially real-time application. So Pixie's is meant for that. Yeah.
A second question. You're focusing on CAD data, but there are also process information, kinematics, and all that stuff. I'm thinking about factory processes. Are you addressing that too, or just focusing on CAD data?
If we think about native support of animation, for instance, in a CATIA file, it's on the roadmap. But there are maybe some workarounds sometime, because we could maybe extract animation from the PLM system or whatever in a way that we can reuse it inside Studio using our Python scripting editor to create or to prepare things for then being animated into Unity, for instance. So I'm just saying that maybe we won't be able to, so far, to load animations that are contained in CATIA, but if there is a way to extract CATIA or whatever, to extract those data and put that into, I don't know, even text file, then we can reuse it inside Pixie's. But it's on the roadmap, especially also for SBX. We want to keep animations. Really, the purpose of Pixie's is to keep the digital continuity from the CAD tool to the final staging tool. So with the time, we will support all this kind of stuff. Yeah.
Thank you. No. Pas une question.
Is it possible in the future to convert PMI, product manufacturing information, into Unity?
Yeah, actually we support PMI information from CATIA and from Siemens.
Yes.
We can display them into our CAD file review, and we are now thinking about how we can put it into Unity. So it's a topic we are addressing. Yeah.
The first step was metadata, and we have to move on to this kind of data, which are basically an extension of metadata, and it will be done very soon.
That sounds great.
Hello. Thanks for the talk. When you're using Unity plugin, are you manipulating the mesh or removing any mesh data at all, or is the mesh data just going to remain exactly the same way as it is in the CAD model when using plugin?
Yeah, actually that's the point, is that we create the meshes. Inside a CAD model, there is what we call parametric surfaces that are mathematically defined, which make them parametric. And what we do, and it's exactly the purpose of PiXYZ, we take this kind of data, we repair them to be able to create then a very good mesh. So what you see in CATIA, for example, the mesh that is being displayed is just for display purposes. It's not for data, it's not optimized for visualization, in Unity or any staging tool. This is the purpose of PiXYZ. We are going to read this kind of surface, which is quite hard to do, to then create the perfect optimized tessellation. So we create on our own the tessellation with the plugin and with all the PiXYZ products.
Okay, thank you.
You're welcome.
Thank you. Maybe last question. Yeah.
How about local coordinates? Are they transferred as well? Local coordinates, are they transferred from the hierarchy in the CAD to?
Yes. What we get from the CAD products, we keep that. So if there is any transformation matrix on the nodes, we just keep them. Yeah. Okay. We have some tools to reset that, bake the transformation to make them, a unitary matrix. But if it's there, you want to keep it, we keep that also.
Perfect. Thanks.
Okay. Okay. Thank you, everyone.
If you have other questions, please come visit us in our booth. We'll be happy to talk to you.